Hi everyone, I'm Sangeeta Lakshmi, Assistant Professor in EC Department in R.M.K College of Engineering and Technology. I'm going to give some introduction about the electronic circuits. Before that, I'm going to show you the syllabus of Unit 1 BJT amplifier, which contains what is load line, how to fix the Q point, and what are all the biasing methods are available for BJT. With this, we are going to analyze different amplifier configurations such as common emitter, common base and common collector with hybrid pi model. Then BJT differential amplifier. Finally, we are going to see multi-stage amplifier. This is the unit 1 syllabus. Today, we are going to see some introduction about the electronic circuit. Then we are move on to the introduction to amplifier. Finally, what is biasing, what is Q point, what is load line. So from this session, we are going to understand what is the meaning of biasing, Q point and then load line. I am starting with the introduction to simple electronic circuit, which consists of BJT and then bulb, finally the push button. Okay. So in this, if the bulb is connected to the positive as well as negative supply directly, the bulb will permanently on, but we want to make on and off. So if you want to make on and off, we need switch. Okay, as you all know that in the home appliances we are using the tube light, fan, everything by pressing the switch, right? So in the AC case, we need two supply, that is phase as well as neutral, right? One is connected directly to the appliances and another one is controlled by means of switch. And the similar way here also the bulb is controlled by the switch. Here the BJTs act as the switch. The positive supply is connected directly to the bulb and negative supply or ground is not directly connected to the bulb. Instead of that, it is connected through the BJT transistor. Here the BJT transistor is active, that is the BJT transistor as a switch. How it behave like a switch means, as we all know that we have three modes of operation: cutoff, linear as well as saturation. Out of these three modes, the BJT is behave like a switch in the case of cutoff as well as saturation. See here, if we are giving the external voltage source that is given to the base through push button, that BJT will be turned on. If it is on, the bulb will glow, otherwise the bulb in the off push. Okay, this is the best example for the BJT with the switch. Okay, act as a switch. The next example is we are going to see the amplifier. See here, the first block diagram depicts the electronic circuit which require the DC supply to energize the circuit, and the input signal is given to the electronic circuit. It will process some signal processing and finally it will produce the output signal, right? Especially the input signal is analog, the electronic circuit is called analog circuit. The best example of analog circuit is the amplifier. The amplifier requires a DC voltage source, right? This is required for biasing the transistor, because the BJT is the heart of the amplifier. That BJT we have to bias. For that we need a DC voltage source. And another source is signal source. It may be a audio signal or video signal. The signal source, suppose if we are having audio signal coming from the CD player, it is connected to the amplifier, that will amplify it. Then the output of the amplifier is connected to the load, which is nothing but the speaker here. See here, where we are seeing this kind of amplifier is, have you all seen the public addressing system, right? In the public addressing system, you are speaking any signal, the audio signal can be captured by the microphone, right? That microphone output is connected to the amplifier, then the output of the amplifier is connected to the speaker. Suppose if you are not using amplifier, directly the microphone output is connected to the load, that is speaker, means the output of the microphone is not sufficient to drive the speaker. So you could not able to hear any sound from the speaker. So we need amplification. This is one of the application of amplifier. Another one is, for example, if you want to capture the image from the space, right? That captured image has to travel to long distance in order to reach the earth station, right? So definitely if the signal is traveling to long distance, means that will be weakened. So in order to boost or increase the amplitude of the signal, we need amplifier. So these two are some of the example of the amplifier. Okay, many applications are there. So in this, the amplifier must be a linear amplifier. Why it should be linear amplifier? Always the linearity means it obeys the superposition principle. What is mean by superposition principle? The superposition principle states that the circuit contains multiple sources. The response of the circuit is equivalent to the sum of the response of the individual sources. That is a superposition principle. Why I am saying the superposition principle here means, see here, this block diagram shows that it requires signal source and DC voltage source. So we need multiple sources. If you have multiple sources, the analysis is complex. So we can use a superposition principle here. So the analysis, we are going to analyze the amplifier only with the DC source. That time signal source is 0. We are going to set the signal source as 0. Only with the DC source means that analysis is called as large signal analysis. If you are analyzing the amplifier only with a signal source, that time if we are setting the DC voltage as 0 means that analysis is called as small signal analysis. Why I am saying it is small signal, that is large signal means you just compare the magnitude, that is value of the signal source as well as the DC voltage source. Always the signal source is on the order of millivolts, 25 millivolts, 50 millivolts, like that we have the input signal from the CD player. But DC voltage is always on 10 volts, 5 volts, 25 volts. When compared to signal source, it is larger. DC voltage is on the order of volts, signal source is on the order of millivolts. So that's why the signal source, right, analysis only with the signal source is called a small signal analysis. The analysis of amplifier only with the DC source is called as large signal analysis. Okay, so next we are going to see what is biasing. I told you biasing is the process of giving the DC supply to the transistor in order to act as a amplifier, right? So the amplifier, the heart of the amplifier is the BJT. So that BJT is a very important. So that BJT we have to operate in a active region. For that we need the DC supply. So that DC supply is given to the BJT in order to make the transistor an active region. No, that is called as biasing. So the definition is, the biasing means the process of giving the DC supply or external supply to the BJT in order to make it as amplifier. Okay. And then what is Q point? See here, the Q point is always we have to fixed at the center of the load line. So first of all, we have to know what is load line. See here, first point A, you can consider the point A. In this graph, in y-axis we have the collector current IC. In x-axis we have the collector to emitter voltage. Okay. So in this, first you can consider the point A. In this point A, when VCE is 0, so VCE is 0 means definitely the collector current is equivalent to maximum collector current, which is nothing but the VCC by RL or VCC by RC. So you will be getting one point. That point is called saturation point. So that point is A. Okay. Similarly, if we are making when IC equal to 0, that is when you are making IB equal to 0, you will make IC equal to 0, because IC and IB, what is the relationship? IC equal to beta into IB. So when IB is 0, IC also 0. When IC is 0, VCE equal to maximum voltage, which is nothing but the VCC. So you will be getting another point which is called as B. So if you are connecting the point A and B, A is called saturation point and B is the cutoff point. If you are connecting these two, you will be getting the load line. This load line is called DC load line because you are giving only the DC voltage. You are not connecting AC signal. So this is a load line called as DC load line. What is mean by DC load line? This is a graphical representation of the output characteristic of the BJT, right? So it will give the exact what is DC load line, right? So the DC load line is a graphical representation of the transistor operation, where we have cutoff, where we have saturation, where we have the active region. So next we are going to see the what is Q point. Q point means present point, right? So I told you the Q point means it is the ideal position, that is without the signal source. We are giving only the DC source. That time the current, collector current and VCE voltage is established in BJT. That is called Q point or operating point. It is nothing but the some value of IC as well as VCE. Okay, so where we have to exactly make the operating point, whether it is very close to cutoff or close to saturation or middle, right? So that conclusion we will get after these two slides. So if you are choosing the Q point very close to the saturation, what happened? See here, if you are fixing the Q point very close to the saturation, a positive cycle, that is portion of the positive cycle, is clipped off. Similarly, negative portion of the VCE voltage is clipped off. So due to that, we will lose the some part of the information. So if we are choosing the Q point very close to cutoff region, what will happen? So if you are choosing the Q point very close to the cutoff region, the negative portion of the collector current is clipped off. Similarly, the positive cycle of some portion of VCE is clipped off. So due to that also the portion of the information we will lose. So always we have to choose a Q point at the center of the active region. So with this we are going to see the next class.